Hello AI agents, welcome to Artificially. In this video series, I'm teaching you how to turn on the confidence score inside Deepface so that you can improve your facial attribute analysis game a little bit better. If you enjoy the kind of content I make on this channel, do not forget to leave a like. Also share this content with others. Click on the subscribe button and turn on the notification. In a face detection task, the confidence score indicates the level of certainty that the machine learning model has in its prediction of whether a given image contains a face or whether a given face matches a known face. This score is a measure of the model's confidence in its prediction, which is typically represented as a probability value between 0 and 1, but that is not set in stone. Okay, so at this point we are in the GitHub repository of Deepface. So the first thing we will do is we'll create an environment where we will install Deepface using pip install Deepface, and inside the repository you will find the installation guide to install Deepface on your local computer. So let's try that. And we will also try to run some codes on the pip install Deepface package and see how it's performing on our dataset. So let's first look at what conda environments we have. So to do that, let's run conda info --envs, and I have created an environment called dfpip for our pip install Deepface. So let's get inside it. Conda activate dfpip. You can also check the installation using piplist, misspelled there, piplist grep Deepface, and now it shows that we have installed Deepface version 0.0.78, which is exactly what we expected. Now we are ready to run Jupyter Notebook, so let's do that. Perfect. So I have created this df notebooks directory to keep my notebooks, and my test images are inside images and test images. Let's see the first one, and the second one is here. So I'll test Deepface on these two images. So let's do that. So let's go back to Jupyter df_notebooks. Let's create a new notebook here. If you go to the GitHub repository, you will see that there is a lot of functionalities that is available with Deepface, facial recognition, facial verification, stuff like that. We are interested in facial attribute analysis, where we'll look at age, gender, race, etc. And you can see that the code samples are also given how to run Deepface on dataset. There is a very good YouTube channel by the creator of this repository, Seren Gill, and he makes YouTube videos on how to run Deepface. I will put a link in the description for his YouTube channel. Okay, so let's run deepface.analyze on our test images. First, let's rename it to facial attribute. Then we'll do from Deepface import Deepface. Then we do import glob, because I like to read files from a directory using glob. You can use OS as well, but I like a glob. I will use OS to just mention the paths for the test image and destination directory. So let's do import OpenCV, so CV2, and let's also import numpy as MP. Okay, so now we can look inside Deepface, and you can go to deepface.py and you can see the code base, and you can also see the back-end models that you can run. For example, you can run dlib, you can run vggface, facenet, etc. So let's go to analyze and see what options do we have. So we're in analyze, and how the code structure is written is that we're detecting emotion, age, gender, and race. And the backend detector default is set to OpenCV, and we need to pass an image path. We need to give what attributes we want to analyze. In our case, we are not going to pass anything because we want all 4 of them. Enforced detection is used when you don't have a face in the image or the video, but either that or it's not very clear, and unless you set enforced detection to true, it will throw an error. So we gotta take care of that as well. And finally, you have the detector backends, which are the face detector models that are running in the background, and you can pass retina, face, empty CNN, etc. to it, and the options are given right here. So these are the backend models that are available inside Deepface. So let's do one thing, let's try to run the code with retina face. So I'll pass model backend as retina face. Parent directory is our images and test images, so get it from the terminal, pass it on. Our test images directory is called test images. The destination directory, I want to create a directory with the name test images underscore Deepface underscore backend model. So in this case, it will be test images underscore Deepface underscore retina face. So I join to create the path with parent directory and test images directory, and then destination path using parent directory and destination directory. Okay, I will create a try except block just to make sure that I'm making the directories, especially the underscore Deepface underscore retina face, and it will check whether it exists. Otherwise, sometimes it throws an error, so I'm gonna handle that. So if the directory was successfully created, it will mention that it was created successfully. Otherwise, if it throws an OS error, I need to handle that using except block, and it will say that the creation failed. Anyway, in our case, the directory was created successfully. Let's check that. I can see that test images underscore Deepface underscore retina face is there, so that's good. And now I'm gonna read all the images inside the test images directory. In our case, we only have 2 images, so glob.glob, and inside you pass test image path. Remember, not test image directory, but test image path, and you want to pass the kind of data you want to read. In our case, we only have .png files, so it doesn't matter, but it's a good practice to pass on the type of data that you want to read. And I'll pass on star.png because I want to read all the PNG files from the directory. So let's see what's inside the test images directory. So we have 2 images, which is exactly what we expected. So that's good. Now I want to iterate over all the images and read all the images using OpenCV and run the analyze function inside Deepface, and then output the bounding boxes on top of the test images and output that inside the destination directory. So to do that, let's set the file name for the destination file name. So I want to keep it same as my input file. I just want to add something to it. So I want to put it in the destination path, and I want to pass it as image. In case you were wondering why I did image dot split, it's actually really simple. I want the name, for example, 01 078.png. I want the same name as the output inside the destination directory, which is why I'm sort of mentioning this file name, which is my absolute path that I want to pass on. So just an example, if you do take the first example from the all images list and you split it with slash, you'll see that you get the individual components, and I'm interested in the last one. So after I split, what I want the last component, so -1 gives you the file name. So that's what I'm gonna try here as well. So I want to put it inside the destination directory here. Okay, so I'm gonna split the file name and take the file name using -1, and I am done. Okay. So now let's read the image using OpenCV, and the image path is called image, and I'm saving it in a variable called img. And for backend, you can choose different formats. I'm gonna copy this code from the GitHub repository. Let's mention the image path. I don't need the img at this point. I'm gonna use it later when I'm overlapping the bounding box on it. The detector backend is my model backend, which I have mentioned in the second cell. The backend model is retina face. Let's run face analysis and see what output we get. I'm gonna just run the first one, which is why I'm using this break, because I don't want the output from both of them. Just the first one is fine. It will take a second to run, and here we go. We have the output for emotion. We have the dominant emotion, which is happy. We have the region. If you want to output it properly, just use another cell. It's a little bit easier to see. So dominant emotion is happy. We have the region of where the face resides. So here it's given as the top left and the width and height of the face region. You have the edge. So let's check if it's consistent. So we are checking 01078. So it seems like the dominant gender is perfect. Dominant race is Asian, which is absolutely correct. Age is around 45, which I'm gonna say is okay for this example. Okay, now we can move on to writing the whole thing. We're gonna move this break and the print statement from here. Let's run a for loop on all the faces, and you have to run this for loop because in case you have more than one face in one image, you need to iterate over every one of the face instances if you want to draw the bounding boxes on the image. So for faces in face analysis, which is the output, what I'm gonna do here is that I'm gonna convert this width and height into a proper top left and bottom right, which is usually the output in OpenCV. So faces is the output instance. Emotion, I'm gonna take the dominant emotion that I need. Let's see, I'm gonna pick the dominant emotion from here. Perfect. Keeping it inside the EM variable. Similarly, I will use the other keys from the deepface.analyze output. Okay, so now we have emotion, dominant emotion, gender, dominant race, and dominant gender. Perfect. Output it for both of them. So 45 happy Asian man, happy 32 Indian woman. And now we want to use the open CV, so I'm gonna uncomment the first line and then I'm gonna put text on it. Actually, I think I need the bounding box first, but let's try this. So let's do X1, which is my top left. I'm gonna do region, I'm gonna pick the X, and then similarly I'm gonna do the Y coordinate for top left, and I will use the width and height from region to create the bottom right coordinates. And to do that, what you have to do is you just add the width with X1 and you add the height with Y1, because we are going towards right and we are going downwards, so addition is what we have to do. Okay, perfect. So now we are ready to do cv2 dot rectangle to draw our bounding box around the faces. And we're going to pass on the image instance, we'll pass on the x1 y1, which is top left, and then we'll pass on bottom right, which is x2 y2. I'll choose a color for our bounding box, and I want the thickness 2 for it. Okay. Okay, now I want to put the text. I'm putting the text slightly above the bounding box, which is why I'm placing -5 after y1. And now I'm going to choose a font. Just choose any font, doesn't matter which one in our case. Next, we're going to choose a color. Sorry, we're going to choose the font size of the text. I'm going to choose 0.7. Next is the color of the text. I'm going to choose 000 for that. So let's try black, because it pops out a little bit better on images. And finally the thickness, I'm going to put it as 1. And I'm going to copy these lines 4 times because I want to put edge. I'm going to put it at -30, so slightly above. And I'm going to place all of them equally, so 25 pixels vertically. And finally we can write the output in the file name location, and the output is image. Oh, you will get this output, get this error because we have the edge outputted as an integer, so I'm gonna have to convert it to string. So saved it there, and we should have the output here. Let's see. Okay, so woman Indian 32 happy, looks good. Man Asian 45 happy, looks perfect. And the bounding boxes look perfect as well.